Human eye and the colorful world. Human eye. Study the structure of human eye. Eyes alone do not assure visibility. We can see only if there is light. Hence, light plays an important role. Let us study some properties of light. Have you ever noticed why we see kaleidoscopic colors on an oil droplet spilled in water or on land? To get a satisfactory explanation, let us perform a simple experiment with glass prism. Take a thick sheet of cardboard and make a small hole or narrow slit in its middle. Allow sunlight to fall on the narrow slit. This gives a narrow beam of white light. Now, take a glass prism and allow the light from the slit to fall on one of its faces. Turn the prism slowly until the light that comes out of it appears on a nearby screen. You will find a beautiful band of colors. Why does this happen? Remember, the band of the colored components of a light beam is called its spectrum. The splitting of light into its component colors is called dispersion. Can you recollect the sequence of colors dispersed from the other end of the prism? Having a difficult time? No problem. Just remember the acronym or the short form VIBGYOR. Note the sequence. Violet disperses the most, while red disperses the least. So when you represent the colors, begin from the bottom. Hence, the colors of the spectrum are to be denoted as VIBGYOR. Isn't that easy? Let us thank our friend for helping us out with the acronym VIBGYOR for spectrum obtained using the prism. The Earth's atmosphere acts as a blanket and protects all life forms from harmful UV radiations from the sun. Apart from protection, can you list a few advantages of having the protective envelope around us? We experience different phenomena like advanced sunrise and delayed sunset, twinkling of stars and formation of rainbow. Let us recall the principle of refraction. Light, when enters different media, undergoes refraction. Likewise, our atmosphere contains particles of different size. Hence, every time that the light passes from one layer to the other, the path of the light is deviated or changed. For example, due to refraction, the apparent position of sun is different from its actual position. That's the reason the sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset. How many of us really take time to look at the sky at night? Few of us, right? Because life has become too busy. But do you know what you're missing? Have a look. Remember, there is a saying, if diamonds were as many as pebbles, nobody would bother to pick them up. Some of these phenomenons occur once a fortnight or once in a few years. So this night, take some time off and have a look at the beautiful sky that God has made for us. It is unique. We all love to see the rainbow, don't we? Do you know how a rainbow is formed? Let us recall the principle of refraction. Light, when enters different media, undergoes refraction. Likewise, our atmosphere contains particles of different size. Hence, every time that the light ray passes from one layer to the other, the path of light is deviated or changed. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of the sun. The water droplets act like small prisms. They refract and disperse the incident sunlight, then reflect it internally, and finally refract it again when it comes out of the raindrop. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. You can also see a rainbow on a sunny day when you look at the sky through a waterfall or through a water fountain with the sun behind you. Let us recall the principle of refraction. Light, when enters different media, undergoes refraction. Likewise, our atmosphere contains particles of different sizes. Hence, every time that the light rays pass from one layer to the other, the path of the light is deviated or changed. The twinkling of a star is due to atmospheric refraction of starlight. The starlight, on entering the Earth's atmosphere, undergoes refraction continuously before it reaches the Earth. This gives twinkling effect to the stars. Further, this apparent position of the star is not stationary, but keeps on changing slightly, since the physical conditions of the Earth's atmosphere are not stationary. Before we conclude, let us perform an experiment to understand how particle size is responsible for scattering a light. Here we go. Welcome to the virtual laboratory. Let us perform the activity to demonstrate Tyndall effect. 1. Place a strong source, S, of white light at the focus of the converging lens, L1. This lens provides a parallel beam of light. 2. Allow the light beam to pass through a transparent glass tank, T, containing clear water. 3. Allow the beam of light to pass through a circular hole, C, made in a cardboard. Obtain a sharp image of the circular hole on a screen, MN, using a second converging lens, L2. 4. Dissolve about 200 grams of sodium thiosulfate, hypo, in about 2 liters of clean water taken in the tank. 5. Add about 1 to 2 milliliters of concentrated sulfuric acid to the water. You will find microscopic sulfur particles precipitating in about 2 to 3 minutes. As the sulfur particles begin to form, you can observe the blue light from the 3 sides of the glass tank. This is due to scattering of short wavelengths by minute colloidal sulfur particles. Observe the color of the transmitted light from the 4th side of the glass tank facing the circular hole. It is interesting to observe at first the orange-red color and then bright crimson-red color on the screen. Tyndall effect also explains the reason for the different colors of sun at sunrise and sunset. Light from the sun near the horizon passes through thicker layers of air and larger distance in the Earth's atmosphere before reaching our eyes. However, light from the sun overhead would travel relatively shorter distance. At noon, the sun appears white as only a little of the blue and violet colors are scattered. Near the horizon, most of the blue light and shorter wavelengths are scattered away by the particles. Therefore, the light that reaches our eyes is of longer wavelengths. This gives rise to the reddish appearance of the sun. Eden Philpotts said, "The universe is full of magical things, patiently waiting for our wits to grow sharper. So think beyond the box. You certainly will make through." That's it for now. Bye. The possession of knowledge does not kill the sense of wonder and mystery. There is always more mystery. So keep discovering.